today's mock system design. We're working at a new grad level. That's the understanding. Please correct me if I'm wrong, by the way. Here with
Okay.
Matt. And so we're going to get started right away so we're running a bit late. We're a couple minutes late. We'll be targeting about a 45-minute session with, we'll have 5 minutes at the end for some feedback. So let's get right into it. No more dilly-dallying. Okay, so today we're going to be building a system together. We're going to try to make so last time we did Euro shortener, today we're going to do a Pastebin clone. Okay, so are you aware what Pastebin is?
I've definitely heard of it. I think it's like an app that you can use to just like paste content to and then share a link to that content to other people. That's a general
Yeah,
idea.
yeah, that's pretty much spot on.
Uh,
That's what I use this for as well, right? So it's going to be a website. Users can use the website, and what happens is they paste a whole bunch of text or some logs or whatever text into the UI, and the system saves the UI, gives the user back a link, and whenever the user visits the link again, or when anyone visits the link again, it shows them the text they pasted in a while ago.
okay. Is this limited to text or can it be like images and
Let,
videos or other
let's
multimedia?
just do text for now. So just like what Pastebin does.
Okay.
Yeah.
I see. I see. Okay. So,
And
okay.
feel free to
I guess
write any thoughts you have down as well. This is you should have permission. It should be open canvas for both of us here. So,
okay. Okay. Looks like I'm able to type.
yep.
Okay, so I think the first thing to do is to like go over some functional requirements for this
Okay.
system. So just based on what you said earlier, uh, one is that um, users should be able to like generate links or generate URLs that link to text content, basically.
That links
Yeah.
to user inputted text content. Yes.
Okay. Should be able to generate links to user inputted content. I guess that the user is not generating the link, but like the system is like coming up with like a
Yeah.
link similar to tiny URL, I
Yep.
guess. Just kind of okay. So rather than user should be able to generate links is system should be able to generate links to user inputted data, right? Okay. What else? I think that's like the main. That's like the main one, right? I'm just trying to think
And what
what
happens?
other
What
ones.
happens for users that have a link that was generated?
But okay, if those users then visit that link, they should be brought to that content.
Yep.
Okay, so users with link um, to content should be able to view it um, upon visiting the link.
Yeah. That sounds good to me.
And I don't know. Okay, that I feel like that covers the main ones. I'm just trying to think if there's any other functional requirements for this.
I want to add a functional requirement here, which is
Okay,
that the service should be able, the system, the service, should be able to track some basic analytics for the page. So, for example, monthly visit stats for the URL.
okay. Um, and you said that, for example, like monthly visits to certain links, or
Monthly visit to every link for each link with some monthly visitors.
oh, okay, okay, get it. Um, each link. Okay, cool. Um, yeah, if that's that's good for the functional requirements. Then what are the non-functional requirements?
Non-functional.
Okay, one question I have
Yeah.
is, do we expect this, do we expect users of this system to be located across the globe or just in one particular geographical location?
They can be global. Yeah.
Global,
Mm-hmm.
okay. So,
They can be global.
what does that tell me?
I will quickly also mention, just to keep us on track and on time, that yes,
Yeah.
users can be global. There's no restrictions on the geography of the users, but I want to focus on making the system highly available above all else, including performance.
Okay, so we want it to be highly
That's right.
available.
Yes.
So that, I guess that what that would entail in our system is that whenever we want to visit a link, like that should reliably, no, it should be able to bring us to that content. Like it shouldn't like crash or anything.
Yeah, that's the bare minimum. I'm thinking availability also in the context in this case. Then we're saying that it can be a bit slower, so it might take a little while to redirect us to the content. It might have a bit of
Okay, but
loading
it should
times,
eventually,
but we want it to
eventually.
never go to the wrong link. We want to never. So for example, so always we want it to be 100% correct, and so the correctness, that's durability, and availability, as in like we don't want to time users out. We want to be able to handle all the requests that come in as they come in.
Okay, no. Okay, and I guess scalability is kind of a given that we want the system should to be able to handle like large amounts of users
Mm-hmm.
visiting these links.
Yeah, yeah. If it doesn't scale, then it won't be available if you have high requirements. So yes, that is a
Okay.
that's true. Yes.
Okay.
Mm-hmm. Do you want?
Okay.
Yeah. Do you want to put just for my purposes? Do you have any ideas for the numbers on the scalability aspect? So what sort of range of users are we designing this for? And this can be up to you. I want to just hear what you're comfortable with.
Oh, okay,
Mm-hmm.
okay. I yeah, I haven't really thought about like how many users actually use Pastebin, but maybe it's somewhere in the millions, like in terms of like how many people use it on a daily basis. I want to say maybe like 10 million. Is that too much or too little?
2 million sounds about right. Yeah.
Okay. And then in terms of like how many links are generated per day? I want to can we is it safe to just assume that each user generates one link per day?
That's pretty high, but we can assume that.
Okay.
So in this case, we're saying that each to be clear, right? If each user is generating one link per day, that means everyone is performing writes, like creating links, and nobody is
Yeah.
reading links.
Oh no, we'll get to like how many reads are being done per
Oh,
day.
this is in
So
addition to that. Okay, yeah, okay. Let me wait for that.
I assume like with like most systems there's gonna be like more reads than
That's
writes,
right. Yeah.
right? So okay, if there's like 10 million links being generated per day, then maybe I don't know what's a realistic number. Maybe like 100 um reads per link are
100. Yeah.
being done per day.
Okay, 100 reads per write. Yeah, I'm happy with that. Yeah.
One link per user per day, and then 100 visits per link. On average, each link gets 100 visits. Okay. Okay, and then in terms of other calculations, I want to maybe estimate like what is the size of the content, the user inputted
Okay.
content on average. I know this can like vary a lot. Like some people paste like entire like essays, whereas some people only paste like one word.
Uh-huh.
So I'm just trying to see like what's a good average number. Um, okay, something like one character is like 2 bytes. Maybe on average people write maybe like 200 words. Um, 200 words per link,
Okay.
which means like 400 bytes per link. That seem reasonable?
Sure. And how many bytes would your link be, just for curiosity?
Sorry, can you repeat that?
Yeah, I'm happy with 400 bytes of content per paste. I'm happy with that.
Yeah.
I was just remarking that uh, that is not a substantially larger amount of bytes than the size of the link itself. But that's not an issue. I'm just remarking that. Okay, I'm happy to go with 400 bytes per link, per paste, which is the same thing as per
Okay.
link. Okay. Yeah. Yeah. Good.
Okay. And then like so from these numbers we can generate, I mean we can come up with how many like how much storage we need
Okay.
per day.
Yep.
So if there are 10 million daily active users and they generate one link each per day, then in total that's like 10 million links per day. And then if we're saying that there are 400 bytes of content per link,
Mm-hmm.
uh, then we come up with a number of how much data is being stored per day. What does this come to? Uh,
Quick math.
so I'm gonna whip up my calculator. That's like 400 billion. So that's like 400 gigabytes around 400 gigabytes of uh, content being uploaded per day. Okay, so that's the amount of content, like new content, we need to store per day. Um, uh, in terms of how many servers we need for that, I don't know. What was a reasonable amount of storage per server? Maybe
Mm, we you're saying
fi
for
500
uh
gigabytes.
we can do a bit more than that. We can say, I mean, in terms of server, I want to be clear here, right? This is storage, right?
Yeah,
So we're just determining where to store this. Um, we can
yeah. Actually, 400 gigabytes is not that much. Like my laptop has more than 400 gigabytes of memory.
I want to just clarify one thing here.
Uh,
10 million links per day, 400 bytes per link. Where did 400 gigabytes come from? My calculation is 10 million times
oh,
400. It should be 4 gigabytes.
oh, 4 gigabytes.
I mean, how
Wait,
did you calculate
I might have
400? Can you tell me?
I might have done the calculation wrong. So I just did like 10 to the power of. Oh, I see what I did wrong.
Yeah.
It should be I'm off by a factor of 10, I think. So it's like 4,000 gigabytes more like.
Uh, so
Or did you
what's
get something else?
so 10 to the 10 million? So that's 10 to the 6, right? This is
Yeah.
this is east. Oh
Oh, this is
my
actually 10
goodness.
to the 7.
Where the hell is
10
my?
million is 10 to the 7.
So this is 10e6, and then this is 400 is 4e2. So you add the 6 and 2, which is 8, and you have 10 here. So this is like 1e7. This is 1e7. 7 plus
Oh,
2 is
okay. It
9.
only,
So
yeah, it
9.
is only four
So it's
gigabytes.
4.
It is only 4 GB.
Yeah.
Yeah, yeah. No, I did the math wrong. It is only 4 GB.
4 gigabytes. Okay.
So actually, okay, that's not actually not that much at all. Huh. Okay. Interesting.
Okay. 4 gigabytes per day sounds pretty lightweight. That's fine.
Yeah, okay. And then assuming 100 reads per write, then I guess 4 times 100 is equal to 400 gigabytes needs to be served to our end users
Mm-hmm.
per day.
Yep.
Okay, that doesn't seem that much.
Mm-hmm.
Okay, and then I want to go back to one thing, which is like for each like user inputted content, there should be a link that's generated that links to that content, and those links should be unique, right? As in, each link that's generated will map to a unique page. You will not have like
Yes.
two different links linked to the same
Yeah,
page, right?
that would be considered incorrect, right? So yes, that is definitely a
Yeah.
requirement. Yes.
Okay, cool. Okay, yeah, I'm just thinking like where to go from here. In terms of like
Let's talk about.
components.
So as like, let's quickly finish the thought on the data storage. So I like the
Okay,
analysis on the throughput requirements, so the read and write requirements so far of the system. We need to actually can we just quickly think about the schema of how we'll actually be storing this? Like how will this actually be stored?
oh yeah, sure. Okay, so in terms of the text content, I think I'm thinking of using some kind of uh, uh, object store, something that's good for storing like very potentially arbitrarily large like unstructured data. So some kind of object store would be used for that. And then in terms of the metadata for this content, oh, one thing I didn't ask is, should I worry about like if users can like create accounts,
No, we don't
or
need to
is
worry
this
about
like completely
any.
public?
Don't need to worry about that for this.
Uh,
That
okay,
is fine.
okay, cool.
Yep.
Huh, okay. Yeah. So I guess in terms of the metadata, what metadata would we need? Maybe one thing that could be useful is like creation time. One other thing which comes to the top of the head is maybe like a time to live counter. After which like the content just gets deleted, because if we don't have that, then like our data can get arbitrarily like large.
Okay.
Okay, so just like writing this stuff down. Okay, maybe the schema called I don't know what should we call this schema.
Let's not bike shed. Just make up a name and move with it.
Maybe creation time, expiry date, and then there should be like some kind of ID for the object that we will use to grab it from the object store. Content ID.
Okay. So this is your
So creation time,
this is your
expiry date.
metadata table here, right?
Yeah, yeah.
Is there a reason you're storing both the creation and expiry?
I guess if we don't really need the creation time, come to think of it, like we don't actually need the creation time. It's maybe just like something that's nice to have, but not needed.
What if
The only thing we really worry about is like the expiry date, because that's the thing that we're going to be checking to determine if we need to delete this from the data store.
What if we do it the other way around? Like with the creation time, you can still know if a object should be expired, right? And with the creation time, you get a bit more flexibility. For example, you can show the user when they created it, etc. You can sort it by creation. So maybe we can achieve the same functionality. We can get rid of the expiry date and just keep creation time.
Oh, yeah. I'm just thinking like, if we get rid of expiry date, then when will we know like to delete it?
If creation time plus our known interval is greater than now. So your TTL is, let's say, wait, did you say what your TTL is?
No, I think that's something that we can determine.
So let's say arbitrarily your
Uh,
TTL is in seconds. So if creation time plus in seconds is greater than now, you know it's expired. Or no, if it's greater than
okay,
now, you know
okay.
it's
I guess like if we're assuming like a constant TTL for like everything, then
well. If you're not assuming a
yeah, that's
constant
fair.
TTL, then yeah, then you would need both or
Yeah, yeah.
expiry time.
Okay.
Yeah.
Okay. So I guess really like that should be enough like for
Okay.
the metadata.
I'm happy with that. Can we
Um,
do two things here? I wanted to just clarify. So your content ID is going to be the primary key for this table.
yeah.
Okay. And part of the metadata also requires you to not necessarily the metadata, but you also need to determine the link.
Oh yeah,
That can be
that's exactly what I was just about to mention something, which is the link, which should be auto-generated by our system.
mm-hmm.
I'm thinking this could be like some kind of random, like fixed length string that's randomly generated by our system. Now obviously with random like strings, like there's a chance of like collisions where say we generate a link for one page and then we store that in our object store, but then sometime later our system happens to generate the same link. I think in that case, one option is just to like re-roll the dice, just
Okay.
regenerate.
Yeah, just reroll it. Yeah, I'm happy with that.
Um, yeah. So the other thing we need for the content metadata is like the actual URL.
Mm-hmm. Okay.
Yeah.
Great. And let's talk a little bit about the actual content. So you have a content ID here. Can you tell me where the content is being stored?
The content itself. Mm, yeah, I mentioned like object store earlier.
Mm-hmm.
But actually, you know what? If we are just storing text data, we, like we're not dealing with any like photos or images. I think a simple document store it should be okay as well.
Okay. And so what would that
Not
look like?
necessarily have to be uh, a blob store.
Mm-hmm. Okay. Is there
Mm,
going to be a schema for that, or are you going to put it with your metadata, or what's the situation here?
yeah, actually, the more I think of it, like the more I think like, we don't need like two separate storages for this. Like we could literally just have like the content like over here, like the content, uh, and then this whole thing is just like a document database. Um,
Okay.
yeah.
And what if the content is very long, very large? You didn't set a limit
I
for.
think we should impose like some kind of limit
Okay.
for how long the content can be, so that it doesn't put any like strain on our system.
What's the
You don't want people like
what's the limit?
what's the limit? Okay. I don't think we want people to be uploading like entire novels. So maybe a reasonable character limit, let's just say it maybe like a 10,000 character limit.
10,000 character. Okay.
Yeah,
Sure.
10,000 character limit.
Okay, let's put that down. Sounds fine. You said a character you're assuming is 2 bytes.
Yeah,
So 20 kilobytes. Okay.
yeah, 20 kilobytes.
Okay, great. Sure, we can proceed with this data store. Let's talk a little bit more about so the client, right? Someone goes to the website, and we know for this case we don't have to design the website. You can assume it's already made. Some other team members making the website, right?
Hmm.
The client makes a request to you. Where do they hit you first?
What do we?
Yeah, so are they going to be
Um,
making requests? Is the website going to make direct requests to this database, or will there be something in between? Well, like what kind of components are we thinking of putting in for this?
okay, yeah, yeah. So I think okay, in between the client and the database, there will be there will be like some web servers that handle the various requests that the clients can make. Like, let me just define like some APIs that the client can call.
Okay.
One of them, okay, there's like two main things. There's like read, and then there's write,
Mm-hmm.
or like generate. Yeah, generate. And then for read, all that takes in is the URL for content. And then generate, this should take in um, the content and the um, creation or like current time.
Does it need to take that in as a parameter?
No, I guess it could just be automatically. The current time can just literally be determined by a call to like any like date.now.
Yeah.
So from the user perspective, all that needs to be sent is the content.
Yeah.
Right. And then like so in between the client and the data store is going to be like web servers that handle these API calls.
Okay.
Yeah.
Let's talk about these API calls. You have these two APIs. You have let's call it read and write. Okay, keep it generic. Read and write.
Hmm.
In this case, if you only have one table, they'll both be reading and writing to this one table, right?
Yeah.
Okay, that makes sense. What are some limitations here, right? So let's this is pretty high level
Oh,
stuff.
yeah.
Um,
Yeah, so one limitation is as the number of reads and writes get really large, or as the system gets like highly concurrent, there will be resource contention in terms of like, if I want to read to this table,
mhm.
if I want to read from this table, but someone else is like writing, then what should I do in that case? Well, obviously, if they're actually, there is no API for update, so that shouldn't really matter. Because I was thinking, if you want to read a URL
Mhm.
which someone is like updating the content for, then we don't want to allow that. But since we don't have any API for like update, which updates content at a URL that already exists, then we don't need to worry about that. The thing that we need to worry about is simply like the number of users that are hitting our database.
Mhm.
So one strategy that we could use to address that is to replicate our databases basically, so that we can distribute the user requests, or like the requests to read and write more evenly. So our no single database is being overloaded.
Okay.
Yeah.
In that case, so we're saying if we just draw this out a little bit, I want to clarify this one. So let me actually, you know what to do is I'll just go to the right of this a bit. We have a client, right? A client is hitting something. We can talk about that later. And you have a web server here, right? So this is your web server. Okay. your database. Okay, magical drawing. Your database is over here. And previously, the risk was that if you read and writes, this is a single point of failure, right? You can overload this database.
Yeah.
You're saying you're replicating this database now. Okay. So you have multiple databases. You have DB1, DB2, right? Um, okay, that makes sense. But let's say you have a write request. What do you do? If you write it to one, the other two won't be updated. So replication in this case it can take a bit of time.
Yeah, yeah, that's definitely true. Let me think about this. Okay, so if we're just writing to that one database,
Mm-hmm.
the other databases do not get the update, at least not right away.
That's right.
Yeah. Okay, I guess so. One like really like dumb strategy, maybe not dumb, but like the first thing that comes to mind is that we do not call a call to write to be complete until like that data is replicated is replicated across all the replicas. Now, like the
Okay.
downside of that is obviously that will incur a lot of latency as it takes time to replicate data.
That's true. Yeah.
Yeah. There.
Can we be a bit more precise there? So you're saying, so can you clarify? So you said, right, there's going to be some latency before the replicas have the most up to date writes.
Yeah.
What sort of order are we talking about there? How long are we, like 10 minutes, 20 days?
No, 10 minutes is definitely not good.
So how long are we waiting here for them to do
Okay, let
something?
me just think. What? Um, I guess a couple of seconds should be acceptable
Mm-hmm.
in
Okay.
my opinion. I know like this is just a real life
Yeah.
example, but in like YouTube, for
Mm-hmm.
example, I noticed that the like view counts on videos, they're not like always consistent. Like I've watched a video on YouTube and then I've refreshed the view count and it's still like it hasn't changed.
That's
Like
right.
it only changes after like maybe like 5 minutes and then I'll see like the updated counter.
That's right. That's true.
So in this case, I think it's some level of like latency for this process is acceptable. Maybe up to like 30 seconds
Is there?
should be acceptable.
Yeah, that's fair. But is there a way to perhaps always know in this case, or maybe not say always know, but you're saying okay, you're basically saying if a read replica doesn't have this key, you can't know if that key doesn't exist or if it hasn't been propagated yet,
Yeah.
right? Is there a way you can know?
Is there a way that I can know if I'm trying to read URL that it hasn't been propagated yet?
Yeah.
Yeah, let me think about this.
We know that one database, the master, or whatever you want to call it here. I'm just assuming using SQL language here. It doesn't really matter. Um, we know that one database has to be the source of truth, right? Like you're saying this is you're saying that you have one database which accepts um, the writes, and you have other databases that might handle some other load. Is that the case? In other words, we should be clear. We should be a bit more explicit, a bit more clear here on.
mm,
We have multiple databases, and some of them might not have the latest information on, right? In this case,
yeah.
we're saying that all the writes are going to one database. If they're going to all the
Or
databases, then
actually, not necessarily. Like the rights could go to they could directly go to any of the replicas.
okay. So this is end to end. So that wouldn't be necessarily a replication. That would just be a network of nodes. Okay, I see. And how are you determining which database it should go to?
I'm thinking
Let's do
yeah.
horizontal sharding.
Yeah, horizontal sharding. I'm thinking if we do horizontal sharding, what should we shard by?
Let's shard by the
Um,
ID, the
one,
URL.
yeah, I mean, like, we don't have that much metadata to shard by, so like the only thing that we could use is probably like uh, maybe like the content ID.
We can shard by the URL because
Shard by the
that is the
URL.
only information that the
Okay.
web server has.
Okay, fair enough.
Right, so we can say that we can shard the databases. Let's say that we're using ASCII URLs just for the sake of the argument. That means there are, well, let's be even simpler. Let's just say we're using alphanumeric, lowercase alphabet plus 10 digits. That means there are 36 possible first characters of the URL. Correct?
Yeah.
Correct. So we'll have 36 databases. Okay, and database one will handle all URLs that start with the digit 0. The second database will handle all URLs that start with the digit 1, and so on and so forth.
Mm-hmm.
Can you walk me through the logic now?
Yeah. Okay. Now, like, not every replica has the same data. Like,
Mm-hmm.
it's the data is being partitioned into like these buckets. So that I think that would lessen the load on any one particular replica.
Yeah. And
Yeah.
so can you comment on the correctness? That's the part we're trying to solve, right? Is previously you don't know if an ID doesn't exist because it doesn't exist or because it hasn't propagated. Can you now comment on whether that problem still applies?
Right. I don't think that problem applies now because if a user wants to make a call to read,
Mm-hmm.
um, like the system should know. The system does know like which replica. I don't want to call it replica anymore. Which shard,
Mm-hmm.
like which shard,
Yep.
um, contains that data. And if it's not there, then we know for sure that that data just doesn't exist yet. Because we know the only place that that data can exist is that one shard.
Exactly. Very good.
Um, yeah.
So in this
So
case,
that old problem does not exist anymore.
great. So, and I want to be clear here, the system you're talking about is specifically the web server, the system which receives a request from the client, right?
Yeah.
Okay. Now, the next question I want to ask is, our web server is one machine in this context who can obviously perform some number of read and writes to our various databases, which is great. But this web server is now also a point of failure, right?
Yes. Mhm. So yeah, our web servers, we should have like obviously more than one web server to serve these requests. So I think in between the client and the web server should be a set of load balancers instead
Okay.
to prevent the single point of failure problem.
Okay. Can we sketch out what that might mean for a
Yeah,
specific client?
great. I can I edit? Yeah, I'm gonna try to move clients
Yeah, that's fine.
up a bit
Yep.
to make more room. Wait, where's the pencil? Oh, there it is.
Number 7. Yeah.
I'm just gonna draw a load balancer.
That's fine. You could also just write load balancer, but it's the same difference.
Okay.
I don't care.
And then this is gonna be like web server. This is gonna be a web server. This is gonna be a web server. This is also a web server.
Mm-hmm. Just to clarify the hierarchy here, does this web server here still exist, or is this like just part of your stuff over here?
Oh yeah, yeah. No, you can assume like this big red web server is like is at the same level as
Oh, so it's just like over here.
the black ones. Yeah, yeah, yeah.
Okay,
Yeah,
and then this one doesn't exist, and this line over here. Okay,
yeah, yeah, yeah,
okay,
yeah.
okay. Yeah, makes sense. And tell me
Um,
what's going on here. So why is it that this one can now alleviate the problem of one web server going down.
Yeah, because if one web server goes down, like there are still obviously other web servers that can handle these requests, and I don't think these requests are stateless. So it doesn't, because one web server goes down, like it doesn't really affect anything because the it is a it is stateless. We don't have to worry about like things being stored on the web server that could be important to functionality.
Okay, that makes sense. That's good. And maybe one last thing I want to talk about before we do a bit of feedback on this one, is I want to talk about any, like just at this level of granularity, where we can get some more performance. So where do you think the bottlenecks
Okay.
could be in this case? Keep in mind that you're saying, right, in this case you're saying that we have a 100 to 1 read write ratio. Okay, so
Yeah.
what might be the bottlenecks in this case in terms of performance?
Okay. 100 to 1 read write ratio. Um. Hmm. Maybe I'm just trying to think if there's like some particular links that are especially popular, what would happen to our system?
Mm-hmm.
So say there's like a really popular link, maybe some viral meme
Yep.
that's being stored in like this, that's being stored in this database here. And because it's viral, we have lots of clients that are requesting to read what's in there. So in theory, that could introduce a lot of load on this particular this database instance.
Yes.
And if it becomes too much, then that could lead to increased read latencies. Yeah.
Okay. Yeah.
So I think, yeah, that kind of makes me think that it might be good to have some kind of caching layer in between the web server and the database layer.
Okay. And
Um,
can you tell me what will be in this cache?
then this cache, it would store the same thing as the database, as in like the links,
Yeah.
and
So
then
we'll store
the content
links.
of those
So
links.
maybe like
Uh,
which links will you store? You can't store all the links in the cache,
Yeah, we're not
otherwise.
going to store all the links because like the memory
Yeah.
of the cache is going to be a lot smaller than the actual
Yeah.
database.
So what links will you store?
So it, I think what will end up being stored is like the ones that are most popular. If we use some kind of eviction mechanism, like maybe least recently used or maybe least frequently used.
Okay.
Because
Okay.
then if we use least frequently used, then that would mean like the really viral links are gonna end up like staying in the cache, while the other not so popular ones are gonna be kicked out. So that would reduce the latency of in the case of there being like really viral links.
Okay. Yeah, that's a pretty good answer for that cache. So I want to pause this here. Um, Great. Let's start with you. How do you know my first question always is how do you feel? How do you think it went?
Honestly, I feel like my biggest struggle with this interview was uh like holding my phone with one hand while typing with the other, because if I don't do that, then I feel like your volume it just ends up being like a little bit too quiet.
Yeah.
So that was a struggle. I don't know why. I should figure out like how to get my Discord audio settings in properly.
Yeah. Well, we had a mock before, right?
Yeah, and
Yeah.
it was
That
fine
time was
then.
fine.
I don't
So,
know why.
because the first time I usually tell people, hey, audio check, go to Discord settings. I was like, oh, yeah, you were fine last time. We can just whatever. Okay. Well, now I know. No matter what, if we had an interview
Yeah,
before,
yeah,
so I
yeah,
know. Okay, that's for me next time. I'll make
yeah.
sure that happens. Um,
But in terms of like a struggle with the interview itself, I think my biggest struggle was just knowing like when to move on to like the next step.
mm,
Like after I was pretty good with like going straight into functional requirements, but then I wasn't really sure when I should move to like non-functional requirements and when I should move into like resource estimation.
okay.
and then when I should move on to like the like
Yeah.
coming up with the different
Yeah.
components.
Yeah.
I think you noticed that I was like waiting for you to like prompt me to go to the next parts. I wasn't
Hmm.
sure about that.
I mean that's easy. Just ask. Are we happy with the functional requirements? Okay, I'm going non-functional. Are you happy with this? Okay, go
Oh,
into component.
okay.
Just ask. That's not an issue. Um, of course, you can say it more topically. Like for example, oh, are there any more functional requirements? No. Okay, I'm moving on. Are there any more non-functional requirements? No. Okay, moving on. Right? Are there any more
Okay.
considerations for performance we need to make? Any more napkin math we need to do? Are we happy with this? Okay, moving on. Now, there's a couple things I will say before I move on. Before I move on, as I will say about the estimations. Um, Aside from the
Mhm.
math error, which is like just be careful next time, there's three categories of performance that you need to be thinking about, right? The first thing is data. So data, it's always about data, right? The first thing with data as in the data generation, right? So you did a pretty good job going for the use case, users per blah blah blah, links per blah blah blah, right? Um, so this was a good start. I will say first of all is that 400 bytes per link is so low that some people will consider that to be wrong. Okay,
Oh
okay, like
shit.
that
Okay.
is like the way you should be thinking about this is I think this is just an experience thing, to be honest. I don't know if you can know this, right? Like you said, 200 characters per link. 200 characters is like not even one line of text. That's not 200. Like that's like one or two lines of text is 200 characters, right?
Oh shit.
Pastebin is used when you have to share something that is too long to be pasted in Slack or pasted in like a typical sharing platform, right? So you have to use
Oh
Pastebin.
right.
So the premise here, some people will say that this is like you just didn't understand the assignment, 400 bytes per link. Like this is just too low.
Oh
Okay,
yeah, that's true.
that's kind of the first thing. Okay, now I'll give you a bit of context. You probably like all of Shakespeare is 1 megabyte. All of the stuff you wrote is 1 megabyte. Okay,
Oh.
so that's sort of thing. Okay, like a person's life writing is about 1 megabyte. So that should be your gauge for whether or not something is reasonable or not, right? So
Okay,
something
so it's actually not that much.
it's
Like
not that if you're
person's entire life rating is
yes
actually
yeah
not that
person's entire
much.
life rating is about 1 megabyte. Okay, so that's kind of the magnitude you're thinking about, right? Now
Okay.
this is pastebin, so it's text only. Now, another thing that you have to keep in mind, right? Images. What's an image? We're not supporting images. I'm not saying it wrong, right?
Yeah.
But images. What's an image? An image is also about 1 megabyte. Okay,
Yeah.
so on your own, you should study what are the sizes for common things. What's a text? What's an image? What's a video? What's like all the different media
Yeah.
types, right? Go figure it out. Like what's a typical thing? Because that way your estimation won't be like whoa 400 bytes. So just keep that in mind. Okay, math problem.
Yeah.
Okay, like that's a bad luck, but you'll be correct on that one because if you said there's 4 terabytes per day, that is way too far off and you can't accommodate that. So that would be fixed the other way, but it's not a good look. Okay, so like go like make sure you do that math correctly on that one.
Yeah. I know, 4 gigabytes. Like when came up with that, when that number eventually got calculated, I was like, whoa, that's kind of small. That's like a USB stick.
Yeah, 4 gigabytes
So
because your
it's
stuff is only four
probably
hundred bytes,
on the low end of things.
right? If you like, it's not. It's here's the thing. Like this 400 bytes is I don't want to say it like this, but I have to let you know this feedback. Okay, it's sort of so wrong that you can't really do analysis on it, and the reason is because in hardware, especially in hard disks, there's something which known as the block size for a disk. I don't know if you've
Yeah.
done
And this.
like
Oh
if
yeah,
you've done
like
like
a block size is like four
a block
kilobytes,
size
right?
is typically 4 kilobytes, and so the
Yeah. Yeah.
smallest, even like a 1 byte thing, will still take 4 kilobytes on disk. So like it's so you're off by a factor of 10 basically, right? Like this is one thing is still going to be one block, optimally one block. I might cross block, still probably won't cross blocks, but so this is actually, even though you said this is technically correct, this math is still wrong because it should be 40 gigabytes per day. So just keep that in, like there are these things you have to kind of think about. Okay, so I just want to let you know about that thing.
Yeah. Yeah.
Okay.
Thanks.
Next, we gotta move along. Just to talk about the next thing. Next thing is you start off really good having a separation between metadata and the content. Okay. Now, yes, you can impose a limit on the content to make that, like you can impose a limit on the content to make that available for just one database read, but that's not actually necessarily better. And in basically almost every single case, it is beneficial to store content and metadata separately.
Yeah.
Okay, and why is that the case? The reason that's the case is because I wanted to. This is a bit of a script. This may be like more intermediate level. The reason I asked you in the sorry in the caching follow up is what are you storing in the cache, right?
Oh
The
fuck yeah!
reason,
The cache should only store like the
yes,
metadata.
your
It should actually
cache should
store
not
the
be
content.
storing the
Otherwise,
content.
yeah.
The content, 400 bytes is kind of, again, a kind of breaks analysis. If this was reasonable, if you don't store the
Yeah.
content in the cache, you can store about 1,000 times more metadata, right? That's a huge deal, right? That is an absolutely huge deal to be able to improve the performance, right? Because you can cache 1,000 times more stuff. So
Mm-hmm.
again, right?
Mm-hmm.
Just be cautious. Like unless there's like a good reason to, just don't store the metadata and data in the same table. There's just no
Okay.
reason to do that for the most part. Okay.
Yeah. What would be like a reasonable place to store the actual data?
So the level
Like,
that
what's
we
an
so
example?
yeah, so the level we got here, an acceptable place would just be a separate table with the content ID and the content, and just store that in the actual database over here, like a database server, and then
Oh,
you can store
okay.
two
Have like
tables.
different
Yeah, and
tables.
then the
Okay.
caching just only mirror the metadata cache, a metadata into the cache.
But if you store like the content and the metadata in like separate databases,
Yes,
would be like slower,
that
right?
would be slower. How much slower? What
Yeah, it would
database
be.
calls how much? I'll tell you, it's about 1 to 10 milliseconds. Okay, if
Okay.
you open the conversation saying, "Oh, 5 second delay is acceptable," then obviously this is also acceptable.
Yeah,
Okay,
yeah.
so that's a non-issue, and you actually
Okay.
save more than that time because keep in mind, right? Remember the index, right? On this content, you'll have an index on the content ID. Oh, we didn't touch on indexes. That's whatever. It doesn't really matter. But
Okay.
one issue is that if you're gonna mirror the content as well into the cache, you're gonna have issues with that one because, again, right, you don't have as much stuff. So the penalty you have from missing something in cache and then having to go to the real database to read it is gonna be way larger than just performing two database reads back to back. So
Okay, that's a good
because
point.
that's a
Yeah.
networking call. You see what I mean? Like that's a networking call. So
Yeah, those are like really slow.
so
Networking
so
calls are really slow.
yeah, so about an order of magnitude, about 10 times slower, roughly. Okay, so
Yeah.
priorities here, right? So that's kind of what you're thinking of. If it's another database call on the same host, networking cost is less than a millisecond. It's just in a database fetch call, which is 1 to 10 milliseconds. That kind of idea. Okay, so I don't want to spend too much time on this one, but like that's the idea here. Store the metadata and data separately. There's really never a reason to store them together. Almost never. I don't want to say never,
Yeah,
but like you know what I mean. Okay.
I think I was going down that route
You
of like storing
were.
them
That's
separately, but then I don't know what made me like not go
Well,
down that route.
because you thought that you can just
Like,
store it in the same table, and yeah, you can technically denormalize or normalize all your tables into one table. But like that, right? So it's a
I think
logic.
it was like the reason I thought it could store in like just one table is because I thought like text content is like small enough. Whereas if you had like videos, then obviously
Yeah,
yeah, you
videos you have
wouldn't
no
store it
choice,
in the same.
but text
Yeah.
content you still have a choice. You don't have just
Mm,
because it's small doesn't mean you have to store it here, right? And it's only small because you
okay.
did something
Yeah.
wrong, not because it's actually small. Okay, moving on. I need to
Okay.
move on to this one. So this is good. Okay, so that's a database. What's the next comment? Blah blah. Oh, okay, yeah. One more thing. One thing you didn't say here is you didn't do any calculations for network throughput. Why is that important? Network throughput
Oh,
tells you
right.
the data that you need to transfer out from your web server. Because why is that? Your web server's read request. When a web server performs a read request for the client, that requires a very large network impact on the web server because it has to return large-ish input, right? And when
Mhm.
your web server is writing, right, when it's writing, keep in mind it does that less often. So 100 to 1 read to write. So there's going to be some different implications there for the networking, right? So just be aware of that. Like, I want
Right.
to see
Yeah.
at least some consideration for the networking. Excuse me, for the networking cost there. Okay, small nit. These things should usually per day is good for deciding what hardware to use. Per second is good for deciding what software to use. Okay, so you should be thinking about per day. You might also want to just freely convert that to per second. Okay, I put a note here: questionable removal of blob storage, whatever, doesn't matter. You definitely still want to consider separate DB from metadata and data. Okay, great. So that's good. Some other feedback here. Sharding is a pretty obvious use case when you have ID you control. Okay, if you can control ID, that means you can shard. So sharding, horizontal scaling. Horizontal scaling is free scaling. Okay, so always be looking for opportunity. One more thing here is we didn't get as far as I wanted at the end, which is to discuss availability concerns. So we discussed availability a bit in terms of increasing the load, in terms of the amount of load we can handle with the load balancers and the web servers. One thing we didn't quite mention was durability, right? How do we know that our system is durable? And one thing, this is something which you can toss out just, off the side, very, very good to just say is that what replication strategy you're using for your databases. Okay, replication strategies are typically good if you want to talk about durability, but not necessarily good if you're talking about low latency correctness, right? Just as you correctly identified,
Yeah.
replication is good for eventual consistency. But you weren't sure, you weren't able to convince me or yourself, I don't know, that the replication speed would have been fast enough. It definitely would not have been fast enough if you chose to use one database, by the way. So sharding was a prerequisite. But now I'm arguing. Now I'm going to say, with horizontal sharded databases, you can now do an arbitrary amount of read replicas per DB. Why is it that now having replicas per DB is not going to be performance risk? Because you control the size of the database. For example, I said this database handles all URLs or IDs starting with 0. Okay, so that means you have 36 databases, right? Let's say it's too big now. We're too humongous. Okay, then what? Then instead of starting with 0, we start with 0, 0.
Oh, you can just like start with like 0, 0.
So now we have 36 square databases. So you can,
but the amount of traffic going to that one shard, it becomes smaller.
Will become smaller, right? So right. Yeah, exactly. So always, if you control the ID, that means if you control how to generate your own sharding mechanism, which you do, where ID or URL, whatever, doesn't matter. If you control that, then you can always control the size of your database, and therefore you can always control the performance impact of replication. Does that make sense?
Mm-hmm. Mm-hmm.
Okay, good. So that was something which you needed to touch on to account for the durability side of things. Durability is all about data integrity on the database layer. So you need to think about what you can do to increase the durability of databases in this case. So, but it's not a big deal. So I think that's fine. That's all the feedback on my side that I can think of. Let me just see my notes. Blah blah blah. No, that's all. Okay. So anything on your side? Any questions you want to discuss before we kind of end it today? We're a bit over time, but I know we started a bit late, so I want to give you a bit of time here. Yeah.
Sorry, just to clarify, durability just means like what happens if like for example one of our database replicas goes down, right? And then how does the system deal with it?
Yeah. So think about this, right? Availability. I'll put it this way. So a system which is highly available but is not durable is a system which you can always call, it always responds, but it might have incorrect data. Okay.
Oh, I see.
A system which is highly durable but not highly available is a system which you can't always call. Sometimes it returns 500, 500, 500. But when it does return an answer, it is always correct, or it is highly correct.
Oh, okay.
So that is the difference between durability and availability. Durability is a correctness of the database at the database, correctness of the system at the data layer. Availability is what's the uptime of the API, right? So that's the difference there. Okay, so what does that mean? Increasing availability means you need to make sure that the client is always able to reach your service. There's a web service available. There's a load balancer available. There's an ENI available. There's all these things available. Okay, durability means that the data is never lost. Like you don't lose data, right? So that's what replicas come in to kind of diversify, a shard or whatever it may be. So that's the difference between durability and availability.
Okay. Oh, so just a question. To increase durability, would one approach be to just increase the number of replicas for each shard?
Yeah. One thing. Yeah. So
okay,
that's something you can do, right? For the purpose of interviews, usually if you mention replicas, that's enough because the answer, right? Then I follow up replica. Okay, blah, 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 whatever. The follow up is how many replicas. Now that is actually a very difficult math question because everything is relatively difficult because that depends on a lot of variables which are difficult to estimate, right? So for example, how durable do you want to be? Oh, I want 10 nines durability. Okay, 10 nines durability. What does that mean? That means 1 in 10 billion failure rate. So that means that you have to figure out, okay, we tolerate a 1 in 10 billion failure rate. We want what's the failure rate of the hardware? What's the failure rate, bug rate of the software? What is the failure rate of a network failure that something failed to replicate? So there's a bunch of these variables now that you have to estimate and are just not really worth the time. So I would say for the purpose of these system design interviews, you don't really need to talk about the quantity of durability or even the quantity availability. you just need to show that you are aware of durability by saying replicas and say you want more
Mm-hmm.
durability.
Okay.
Boom, have 10 replicas. So so
Yeah.
so that's sort of the level that you should be aiming to operate at. So don't go into too much of a rabbit hole determining how many replicas you need for your system. That's usually not in scope.
Okay. Yeah, just one question I had lingering in my mind is earlier you said one thing that I should have done was do some more calculations with regards to like read throughput and write throughput. Uh, if I had like done those calculations, like how would those numbers or would those numbers like affect how I design the system?
I would say definitely. So there's two things here, right? The first thing is if you had done your calculation with 400 bytes, or aka 4 gigabytes per day, you would have realized that you can store your entire database in memory, which is not durable. You shouldn't do that. What I'm saying is that you could have cached your entire table, and what that means
Right. Oh yeah.
is that well, that means a lot of things. First of all, that means that you can be highly performant, so you can scale up to way many more users per day, and that also means
Yeah.
that you know how many requests you can handle per web server. So you can actually answer the question, how many web servers do you need? Because right now you don't know.
Yeah. I was also asking like if I had to come up with a number like oh the read throughput of our system ended up being like uh I don't know 4,000 gigabits per no 4 gigabits per second.
Okay.
Like what does that number
Okay.
how does that number inform like
Uh huh. Okay.
us on like what we should
Yeah. Well,
do
okay. Well,
in
that's just a bit of a knowledge thing, right? So what's the context here? 1 gigabit is it's a speed of transfer. What's the speed of
yeah.
transfer? And that means 1 gigabit is 1/8 of a gigabyte per second, right? So 1 gigabit means that you can that is like residential networking speed, right? You can go to Telus right now and buy 1 gigabit for like $50 a month. Okay, that means that if your service is serving you have a 4 gigabit throughput. Um, for the raw traffic alone, so if you don't care about latency, which I did not say you have to care about, if you don't care about latency, you need 4 servers, roughly 4 servers, and it has
Okay.
right. If you want to have, let's say, like in this case, we didn't define what is a surge load, what is a peak load. We just decided what's the average load, right? So yeah, for the average load, we serve with 4 servers. Yeah, that would be sufficient with that knowledge.
Okay, so
Yeah,
that number would inform like the number of servers that we would need
yeah, that would
to
that would
handle the
yeah, that
load.
would say, okay, if I assume
Okay.
that I'm paying for 1 gigabit
Yeah.
networking for my web servers, then I need 4 web servers to
Yeah.
serve 4 gigabits. Yeah.
I guess I just arbitrarily drew like 4 web servers here, but if I had actually calculated that number, I could have like come up with a
Yes,
concrete number of web servers needed.
that's right. Yes.
Okay, I see.
The reason you do calculation at all is to know how many of a thing. Otherwise, you don't care. We just be
Yeah.
qualitative.
Yes.
Oh yeah, have a thing here, right? So yeah.
Yeah.
Okay,
Yeah, I think a lot of good ground was covered. I think that's it in terms of questions that I had.
great. Okay, then that should be all on my side as well. Thank you very much, Matt. Take care.
Yeah.